Okay, kiddos. Here is little lesson describing how the variables relate to one another in Newton's universal law of gravitation. So Newton's universal law of gravitation describes how two masses attract one another, and we call that gravity. The greater the masses are, the greater the force between them, and the closer they are, the greater the force between them. So the way that looks is like this. So this is F equals gmm over r squared, where g is the universal gravitational constant. That is 6.67 times 10 to the negative 11. And we're not really doing any calculating with these. We're just, well, we're kind of doing calculating, but we're not going to actually have to plug in the value for g. We're just interested in if these things change, so if the mass of something were to double, what would happen to the gravitational force between it and the other object. So let us assume that we have two objects and they are attracting one another. And so this is a single question right here. This is another question. This is another question. So what this question is saying, I just sort of made out some little shorthand notation or whatever. But if big M, so that's one of the masses, this is a little m, that's another mass. If one of the masses were to increase by a factor of 2, meaning were to double. So if one of the masses were to double and everything else were to remain the same, the distances between them and the other mass, what would happen to the force between them? So I'm hoping it kind of makes sense that if we were to put a 2m in here, then we would have to put a 2 in front of the f in order to have this equation be balanced. And therefore we know that what this means, or would indicate, is that the force would increase by a factor of 2. Meaning if it were 10,000 newtons, it would now be 20,000 newtons. Okay, so let's get rid of those 2's and see what happens in this next one. So there will be situations where multiple variables are changing. So what happens if, in this situation, it says that big mass is doubling and then little mass is decreasing by a factor of 4, meaning is now 1/4 of what it was. I'll say that again. So if it's decreasing by a factor of 4, it means it went from 40 to 10, or from 16 to 4, or from 12 to 3. So in essence, decreasing by a factor of 4 is the same as multiplying by 1/4. So if we were actually putting little numbers in here, it would look like this. I saw Taylor doing this today. That was excellent. So big M increases by a factor of 2, so we would put a 2 there. Little m is decreasing by a factor of 4, so it's like a 1/4. So what would this actually do to the force between the two objects? Well, 2 times 1/4 is 1/2, so we would have to have a 1/2 over here to balance the equation, meaning if one of the masses were to double and the other mass were to decrease by a factor of 4, the force, the gravitational force between them would decrease by a factor of 2, or be 1/2 of its original amount. So, and again, you don't, if this notation is weird, just know that I'm kind of writing this because I don't have space to write out all those words. You could describe this as the force is now 1/2 its original amount. It decreased by a factor of 2, or I don't know, you could maybe do like 1/2 f. Same thing. Next up, radius. So radius is different in that the force is inversely proportional to the square of the radius, we say. So as the radius increases, force decreases. That's because this is in the denominator of the equation. Well, mathematically, that's why. And know that the force depends on the square of the radius. So if the radius were to increase by a factor of 3, obviously the force would decrease, but it would decrease by a factor of 9. So how do we get that? Well, we're going to erase this to avoid confusion. And so radius increasing by a factor of 3. So if we put a 3 in front of the r and noted that that is now squared, we could then recognize that, well, 3 squared is 9. This is going to get messy here. So we now have a 9 underneath, and in order to balance the equation, we have a 9 in the denominator, so we would need a 9 in the denominator. So we could say that the force is now 1/9 its original amount, or that we could say that the force decreased by a factor of 9. All right, we're getting. So let's look at a couple more situations, and then we will be masters. If the radius decreases by a factor of 3, meaning they are now closer. So like here's the big mass, here's the little mass, and they just switched to like this. So instead of being this far away, they are now this far away. So notice how the distance between them is now 1/3 the original amount. So this is what this is indicating. Radius, distance between them, decreases by a factor of 3. It is now 1/3. So if we were to plug in a 1/3, that would get squared. So it'd be 1/9. Dividing by a fraction is the same as multiplying by the reciprocal. So it means the force would increase by a factor of 9. Awesome. Woo, I'm pumped. Number 2, oh look, multiple things. So one of the masses is going to increase by a factor of 2, and then the radius is going to decrease by a factor of 4. So they are now way closer together, and one of the masses has doubled. So if we were putting numbers in, we'd have a 2 there, we'd have a 1/4 here. So this means that, so 1/4 squared is 1/16. Move the 16 up. So we have it's doubling and it's being multiplied by 16. So this would mean that the force is going to increase by a factor of 32. Or we could say the new force is now 32F. And lastly, if one of the masses were to triple and the radius, oh this is a good one, were to double. So the force is going to increase because of this, but because the masses are getting farther apart, it's going to decrease because of this. So that's kind of messy. Let's just start over. So we have this, and we have this, and we have this. Whoops. So this increases by a factor of 3. This increases by a factor of 2. What do you think? Yeah, me too. I think that the new force is 3/4 of the original. So the new force is 3/4 of the original because we need a 3/4 over here to balance with this 3/4. That's a 2 squared. So, and how would we phrase that? If the new force is 3/4 of the original, I think it decreased by 4/3? A factor of 4/3. Interesting. Well, that sounds right to me. Oops, pause. Stop.